Hello guys, in this one we make this kind of pattern using Blender geometry nodes. To start, we'll delete our camera and right, we don't need it for now, and then we will jump into geometry node workspace, and we will select our cube and then create a new geometry node. So the shape of the object we have in a 3D scene doesn't matter at all, because we are going to be creating our curve primitive. Here let's add a curve line and then connect it to the output of our geometry node. Let's do it. We will add a set position node, and then in our set position, we will drag out of these and add combine XYZ to separate our axis of the curve. So then you can do this by manipulating any type of any axis that you like. If you want it to be flat on surface, you will affect X and Y. If you want to be looking up, you can affect either Y and Z or X and Z. So let's use X and Y for now. So we'll add a factor, a spline parameter here, and we connect factor to our X position. So what we are going to do is we are going to take sign of our factor. We take the sign of like curve factor from 0 to 1. The factor ranges from 0 to 1. If we come here in our control point, we can see that if we were to visualize this, if we take our line here and visualize the factor, our factor ranges from 0 to 1. So just because we have just one control point, we only have that value. But if we let's do the sample curve. If we sample curve and add more point, you will see that factor will always range from 0 to 1. So now if we set the position of the curve according to this in X position due to the sign of factor, then it will go from 1 to 0. So now let's try to offset it on Y by a cosine of the factor and see what we get. So as you can see, immediately we get the segment of the cycle. So the reason why this happens is because we have only from 1 to 0. So to have a full cycle, we have to remap the factor, and then you can also use indices, but I find factor to be quite easy to work with. So let's add map range node, and then what we do, we take from 1 to 0 and map it from 1 to maybe let's say 180. No. Let's type in here tau. Tau is like 2 pi. If you input tau here, it's like adding 2 pi, which will equal to like a full circle. So the way that we can do that, if you are like me and you understand degrees better, like in degrees unit, then we'll add a value node here, and then we convert to radian. If you will add 2 radians node here, we can simply add our degrees that we want. Let's say for example 90, and it will give us like a quarter of the circle. And if we do 180, we have a half of the circle. So yeah, I think this is more accurate way you can use to make a segment with a certain degrees that you want. So after this, we'll come here. Let's just let's do 360, which is a full circle. and then multiply it with a couple times depending on how many like rotations that you want. Then we take our angle input and then multiply it by by a certain number. Let's also use a value here. Let's say for example 1. So if we multiply it with that number, like this number will determine how the number of turns that we have. Since our first input is a full turn, like a full cycle, this will determine how many turns that we have on our curve. Take these calculations and group them into a group. Let's make a group of these nodes. Because we'll be using them so many times, so not many times, like 2 or 3 times, depending on what you want to achieve. So the first value here is the factor input. So we can, just for us to know what it is, we can name it to factor. The second input is our angle. We can just say angle, and then let's call the last one turns. Yeah, forgive my naming is not the best one. So there's something else that we can do here. We can also adjust our like we can adjust our radiuses depending on if we want to adjust like x radius of the circle differently than the y. We can do it here. We can add our math node and do right. We can use a multiply here to adjust just an x radius. Let's keep it 1. Let's give it default value of 1, and you can also output this one. And you can use the same node over here, and then this can be our y adjustment. So we can call this x radius, and here we can call it y radius. Okay, so now here we can be able to adjust our radiuses differently, and also we can add an overall adjustment, an input here. If we add if we add a float input here and then add it here into the multiplication, let's name this like overall radius. Okay, so yeah, so we can use this to affect our overall radius length, and those want to adjust the radius. Okay, so here we have our base cycle math here. So what we will do next, okay, since we have this, what we will do next is like we can just duplicate this, move it here, and then take our set position node, add it here. So this is crucial. What we will do next, all other set positions, we will offset the position of our base cycle. But if you put this into the position again, it will override that one, and then you will have to, it will be a bit messy, and it will require you too much more calculations to achieve what we are achieving. So we have also our angle of I think here it's messed up a little bit, angle of 60, and then we can, we don't have factor, that's why we have problems. So we can just duplicate our factor there, and then come here and input it here. Okay, so as you can see here, it is starting to look like something. So the reason why it looks like that is that we have a low segment to work with. If we increase our sample, okay, actually we can even add another sample here if you want to, but that one is fine. So as you can see here, as we increase turns, we have much more Yeah, make sure this one is like a full number, because if it's not, it will like cut in middle. Yeah, okay, so if you add to want to increase the radius of the whole thing, you can increase it that way. You can also increase the radius of these individual ones. Also, if you want to like offset it in like inverse way, you can like come here in negative result to return outside. Okay, so one thing that you will notice is that whenever I change turns, if you can see right here, like it is not consistent, it is not staying together, and you will have to just like make a little bit like a small changes to be able to snap it to the like to be like to back together. So I think now I don't think that's a best way to do it. So that's why you have to. I think it's better to change our turns into integer instead of float. Since we will be able to have like definitive turns, and like every time we add the number, it is like a full turn, as you can see right here. So one more thing, I don't know if you noticed that, but if we do like if we add, let's say if we add, we say to add like 3 tons, instead of having 3 we have 2 tons. So the way to fix that is this is only on second level. The first level is fine. So the way we can do that is we can take our tons and then add the one on this level before adding it, before outputting it. So what we will do is take our math node there and put it here. We change it to add, and then we add 1. So let's inside make it 0, because if we put 1 in here inside, it will affect the first level as well. And let's actually output the value of tons outside. So here we can add, we'll add 1, and since, as I said, okay, here it's not affected, so now we can go ahead and let's see. Oh, it's cramping. So keep in mind to like disable cramp. So this time now, if we say 3, we have 3. If we say 4, we have 4. Just make sure that here it is 0, because if it's in another number more than 0, you will have like unexpected result, as you can see here. If you don't want it, like a full circle, you will have to do it over there. So yeah, as you can see, you can be able to create a lot of interesting stuff. And on top of these, you can add another one, and then like add other ones there as well. So this is actually the major node setup, and you can keep iterating over and over again and play around with parameters, increase the segments. Then if you keep trying for a while, you will be able to come up with many interesting shapes. Thanks for watching. Remember to like and subscribe. Thanks.